Orchestral replaces LangChain's complexity with reproducible, provider-agnostic LLM orchestration. A new framework from researchers Alexander and Jacob Roman rejects the complexity of current AI tools, offering a synchronous, type-safe alternative designed for reproducibility and cost-conscious science. In the rush to build autonomous AI agents, developers have largely been forced into a binary choice: surrender control to massive, complex ecosystems like LangChain, or lock themselves into single-vendor SDKs from providers like Anthropic or OpenAI. For software engineers, this is an annoyance. For scientists trying to use AI for reproducible research, it is a deal-breaker. Enter Orchestral AI, a new Python framework released on GitHub this week that attempts to chart a third path. Developed by theoretical physicist Alexander Roman and software engineer Jacob Roman, Orchestral positions itself as the scientific computing answer to agent orchestration, prioritizing deterministic execution and debugging clarity over the magic of async-heavy alternatives. The anti-framework architecture. The core philosophy behind Orchestral is an intentional rejection of the complexity that plagues the current market. While frameworks like AutoGPT and LangChain rely heavily on asynchronous event loops, which can make error tracing a nightmare, Orchestral utilizes a strictly synchronous execution model. Reproducibility demands understanding exactly what code executes and when, the founders argue in their technical paper. By forcing operations to happen in a predictable, linear order, the framework ensures that an agent's behavior is deterministic, a critical requirement for scientific experiments where a hallucinated variable or a race condition could invalidate a study. Despite this focus on simplicity, the framework is provider-agnostic. It ships with a unified interface that works across OpenAI, Anthropic, Google Gemini, Mistral, and local models via Ollama. This allows researchers to write an agent once and swap the underlying brain with a single line of code, crucial for comparing model performance or managing grant money by switching to cheaper models for draft runs. LLM UX, designing for the model, not the end user. Orchestral introduces a concept the founders call LLM UX, user experience designed from the perspective of the model itself. The framework simplifies tool creation by automatically generating JSON schemas from standard Python type hints. Instead of writing verbose descriptions in a separate format, developers can simply annotate their Python functions. Orchestral handles the translation, ensuring that the data types passed between the LLM and the code remain safe and consistent. This philosophy extends to the built-in tooling. The framework includes a persistent terminal tool that maintains its state, like working directories and environment variables, between calls. This mimics how human researchers interact with command lines, reducing the cognitive load on the model and preventing the common failure mode where an agent forgets it changed directories 3 steps ago. Built for the lab and the budget. Orchestral's origins in high-energy physics and exoplanet research are evident in its feature set. The framework includes native support for LaTeX export, allowing researchers to drop formatted logs of agent reasoning directly into academic papers. It also tackles the practical reality of running LLMs, cost. The framework includes an automated cost tracking module that aggregates token usage across different providers, allowing labs to monitor burn rates in real time. Perhaps most importantly for safety-conscious fields, Orchestral implements read-before-edit guardrails. If an agent attempts to overwrite a file it hasn't read in the current session, the system blocks the action and prompts the model to read the file first. This prevents the blind overwrite errors that terrify anyone using autonomous coding agents. The licensing caveat. While Orchestral is easy to install via pip install Orchestral AI, potential users should look closely at the license. Unlike the MIT or Apache licenses common in the Python ecosystem, Orchestral is released under proprietary license. The documentation explicitly states that unauthorized copying, distribution, modification, or use is strictly prohibited without prior written permission. This source-available model allows researchers to view and use the code, but restricts them from forking it or building commercial competitors without an agreement. This suggests a business model focused on enterprise licensing or dual licensing strategies down the road. Furthermore, early adopters will need to be on the bleeding edge of Python environments. The framework requires Python 3.14 or higher, explicitly dropping support for the widely used Python 3.12 due to compatibility issues. Why it matters. Civilization advances by extending the number of important operations which we can perform without thinking about them, the founders write, quoting mathematician Alfred North Whitehead. Orchestral attempts to operationalize this for the AI era. By abstracting away the plumbing of API connections and schema validation, it aims to let scientists focus on the logic of their agents rather than the quirks of the infrastructure. Whether the academic and developer communities will embrace a proprietary tool in an ecosystem dominated by open source remains to be seen. But for those drowning in async tracebacks and broken tool calls, Orchestral offers a tempting promise of sanity.